Kia ora, my name is Hsieh. I am a system software engineer at Jade Software, and I work with the Jade platform development team, which is the team who develops and maintains the Jade platform. For today's insights, I will be going through the synchronized database service available through the Jade platform. I'll be going through three major sections. Firstly, some basic background information regarding SDS, and then some demonstrations showing how you can use SDS from both an operational point of view and from a programming development point of view. So firstly, what is SDS? So SDS stands for Synchronized Database Service. In short, implementing SDS allows you to synchronize your main, aka primary database, with one or more secondary databases, usually across different sites. So why might this be useful? Many reasons, but first and foremost, for availability and disaster recovery scenarios by providing an up-to-date backup system. Availability is the proportion of time your system is operational for its intended purpose. In general, you would want your system to have high availability, which means that you would want your system to be online and functional for as often as possible. But what happens if something does go wrong? If an oddly specific meteorite accidentally hits your primary servers, or if an intern decided to save space on your system by deleting your database? This is where disaster recovery comes into play. There are two key factors to disaster recovery: reducing the time to recover and reducing the amount of data lost. Instead of taking hours to replay transactions on a copy of last night's backup and hoping that the database journals which contain updating transaction information have avoided the wrath of the intern, SDS allows you to quickly switch your secondary to a primary and keep your application up and running whilst you put out fires on your primary. Ideally, you would like a system which recovers quickly and reduces the amount of data loss in a worst-case scenario. However, this often comes at an increased cost operationally in terms of hardware and bandwidth. SDS provides a service which utilizes a secondary database kept up to date, essentially a hot or online standby, with the transactions on your primary database, reducing the time to recover and ensuring services can continue running with minimal disruption. This works through replaying transactions on the primary through transferred journal entries and reduces the operational cost of running a secondary system whilst keeping transactional consistency between the two systems. There are two different types of SDS you can run, also known as SDS subroles. One being the native subrole, which its main purpose is for backup and recovery, and the other being the RPS or Relational Population Service subrole, which utilizes a data pump to essentially pump data out of Jade and into a relational database, like MS-SQL. This talk will focus on SDS in its native role. Before we go deep into SDS, I'd like to address the importance of journal files. Journal files, aka audit log files, records details of updates to the database. Their default location is in your system folder under a folder called Journals. These journals keep track of all the transactions that occur to the database. The difference between the current and archive folders is that the current folder contains all the journals required to recover from a system failure or to abort any uncompleted transactions. The archived folder contains all the journals which are no longer necessary for immediate recovery or to undo failed or incomplete transactions. However, this does not mean they are not important. If recovering from a backup, all the archived journals, which detail all the transactions since the backup, are necessary for recovering all your data. Another important aspect to note is that each database has its own set of audit logs. Although the secondary tries to keep at the same point to that of the primary, if there is an unstable internet connection or otherwise slow processing of incoming audit logs, the audit logs on the secondary may be behind the audit logs of the primary. Some brief terminology explained. A hot, aka online standby, is when a secondary system runs simultaneously with the primary system. This allows things like load balancing of queries such as reporting, or running a relational population service application to pump data out into a relational database on the secondary database. A database can be in a few states. A database that is online, it used to be known as hot, is a database that is currently active and running and can accept database queries. An offline database is a database that has been shut down and the database is unavailable for online users, background processes, or any queries. In other words, the database application hasn't been started. If the database is online and the database is processing an active transaction, then the database is in an updating state. If the database has no active transactions or is in read-only state, then the database is quiesced. In order to transition from an updating state to a quiesced state, the database must reach a quiet point, which is when there are no active transactions. There are multiple ways one can set up SDS depending on the needs of your application and clients. I will go through 3 example ways of setting up SDS: passive secondary, remote active secondary, and hybrid configuration. These examples are also included in the SDS white paper. This setup is shown as a passive online standby, typically used as a quick-to-recover backup strategy. It's passive because there are no application nodes connected to the secondary. This means that the secondary is used mostly as backup for the primary database. The difference in an active secondary is the connection of nodes to the secondary database. This means that you can perform read-only queries on an application server connected to the secondary database, allowing you to access the data for, say, report writing or for relational data pump purposes. Distributing certain processes, such as routine procedures of reporting to the secondary, will allow these processes to not affect the primary, reducing the risk of operational failures and will lower load on the primary. This configuration is considered remote because host A and host B are on 2 different sites, although they can also be on the same site. The advantage of having a secondary at a different geographical location to a primary means that in disaster recovery scenarios, when the meteorite decided to destroy your primary servers in Sydney, you'd still be able to recover and continue operations on your secondary in New York, say. An example of a hybrid configuration may utilize a secondary as a local backup with multiple secondaries on different servers for load balancing. One can partition processes across these secondaries to load balance and provide redundancy. Traditionally, when computing power had restrictions, distributed processes were a way to handle large loads, but nowadays, with modern infrastructure, load balancing and scalability is less of a concern. However, SDS does provide the capability to implement load balancing by workload partitioning across multiple SDSs. In SDS, the primary server sends either journals or journal blocks through the network, and there is an asynchronous worker on the secondary which writes these blocks into the secondary journal, essentially mimicking the journals on the primary. There is a tracker thread which then replays the transactions on the secondary journal into the secondary database. The secondary database is a database node in itself, thus automatically maintains its own cache of objects and follows the same rules with the primary database, keeping the same transaction isolation principles and shared lock semantics. It is ready to assume the role of primary if necessary. In the documentation, you can see that there are 2 synchronization modes available: journal switch and journal block write. In journal switch mode, once the currently written journal is being switched to a new one, either due to filling the journal or by programmatically initiating a journal switch, SDS automatically transfers this journal to the secondary. The SDS acknowledges the received journal and the tracker process reads and applies the updates to the secondary. In contrast, the journal block write mode transfers audit blocks from the primary to the secondary journal when they are written to the journal on the primary. This is done asynchronously and continuously in order to not hinder the performance on the primary whilst attempting to keep as close to the primary as possible. Traditionally, when computer processing power and bandwidth were limited, it was important to consider which synchronization mode to use. However, with nowadays improved computing power and bandwidth capability, the transmission of audit blocks via journal block write is the default. The advantage of keeping in journal block write mode includes minimal data loss and faster database recovery given a takeover. Now that we know some more about SDS and how it works, we'll delve into the operational side of SDS. I will now go through a few steps on how to get started using SDS from a non-SDS system. To make this easy to follow, I will run the primary and secondary on one computer, but the same steps will apply for any Jade systems connected via a specified network connection. Firstly, backup and restore. Firstly, make sure all your licenses are loaded onto your original system. Licenses aren't transmitted to the secondaries, so you need to keep them up to date yourself. Now, let's take a backup of the main database. Before we start fiddling with our system, it's always best to do a JDButil database backup and not just copy and paste files to back up your system. Why? Because many copy and pasting tools do not have any verification of the copied data. JDButil does a checksum to ensure that the copied data is correct, ensuring your data is not corrupt, especially in ways that might not be immediately obvious. So we're backing up the file currently right now. And you can see that it verifies the checksum after each file. We can see now that the backup's been loaded into the specified backup folder. And now we will restore it into that SDS system folder. So we need to close the database, and then under operation, restore the database. We want no recovery because we don't have any journals right now. And we'll specify where we want it to go to. In this case, the specified SDS system. And that restores all the files in. And now you can see it's been restored in our specified secondary database. Okay, we will now set up our ini file with the required settings. It can be useful to keep one ini file across your systems and to use named sections as shown with a common naming convention. By using a common naming convention, it becomes easier to track what is happening with each system, especially if you have multiple, and keeping identical ini files across your primary and secondaries means consistency. This means that if your primary decides to bite the dust and you need the secondary to take over, you can ensure that all the other configuration settings that you have changed are consistent, allowing a smooth transition. Some important things to point out in the ini file: the primary server name refers to the my name you will give a particular site under the syncdb services section. This name is then used as a suffix in the connection param section, which specifies which connection parameters your SDS systems will use. It is important to balance the complexity of different systems with shared ini files. If the setup of your primary and secondaries differ greatly, it might be beneficial to keep individual ini files for each system to keep track of custom settings. Now we will go through how to run SDS admin. So we will start up the database server node on the primary system first. I have set up some commands to get these applications up and running. Feel free to use shortcuts if you wish. And for the purposes of this stage of the demonstration, I will also start up a multi-user Jade application on the primary to run some Jade scripts. I will start up SDS admin on the primary. Okay, you can see that it displays site A primary, and it doesn't display anything about the secondary database yet because it has never been started. And now we will start up the secondary. So we're going to start up the secondary database node. And if you look at SDS admin, once the secondary starts up, you can see that the secondary is there and it says block write catching up, and you can see it's highlighted yellow, which is catching up, and now it's green, which means it's block write synchronized. So what you can do now is you can adjust the refresh interval. If you want to get the latest state of your systems, you can refresh your SDS admin first. However, refreshing SDS admin can cause replay to slow down because it requires the primary to get information sent from the secondary through a network connection. As shown earlier, you can adjust the interval at which you refresh this information, which can speed up the processes running on your secondary. The amount of time it also takes to catch up to get to the site B secondary block write synchronized stage depends on a number of factors, such as the connection quality between the two systems and how far behind the secondary system is. So we can click on site B secondary to expand it and take a look at more about the update state and operational state. When you expand the update state, you can see the transaction IDs, what's committed, replayed, and stable. when you expand the operational state, you can see at what state it is in. When you right click, you can disable the read access and you can re-enable read access. You can also see that you've got particular transaction IDs here of 3016. And now I'm going to run the Jade script to create a few objects. And you can see that the transaction ID has incremented to 3020 and now 3032. I'm now going to purge the demo objects and refresh the screen to update it. And you can see that the max committed tran ID on the primary is 3036. Note that the update state of the secondary is also 3036, which means that the secondary has very quickly replayed the same transactions as the primary. Now we will switch track a little and talk about takeovers. SDS is designed to handle both planned and unplanned outages of the primary system. Example of planned outages include maintenance and disaster recovery testing procedures. A takeover is a process when a nominated secondary database assumes the role of the primary database. There are two major types of takeovers, hostile and negotiated. Hostile is when the secondary takes over the role of the primary without involving the current primary, and is generally only done in the meteorite hitting server scenario, where there is no possibility that the primary is going to recover in a timely manner. This tends to be a destructive procedure, and it essentially removes the previous primary from any role in the system. This also means that if you want to switch back to having your old primary server, you'll need to reclone your current primary and set everything up again. A negotiated takeover is when the primary and secondary switch roles. Advantages of a negotiated takeover is that the old primary, now the secondary, retains synchronicity, meaning that switching back to their previous roles can be done quite quickly. An example of how this will be used is during maintenance of the primary. Say the primary server required hardware maintenance. A negotiated takeover could be performed, which switches the primary with the secondary, and then the old primary, now secondary, can be taken offline. Once the maintenance is complete, the roles can revert back to original primary being a primary and the secondary being a secondary. There are also two kinds of negotiated takeovers, conditional and forced. Conditional takeovers wait until all transactions are committed and swap over at a database quiet point. Forced takeovers give precedence to the takeover operation and attempt to force the aborting of isolated transactions by terminating user processes, which locks that conflict until no conflicts remain. When implementing a takeover in a multiple secondary environment, a change primary message is broadcast to other secondary servers, and the secondary servers close their connection to the old primary and connect with the new primary. Now we will look at SDS admin for our two systems again, and we will attempt to execute a negotiated takeover. Okay, so first of all, on the primary, we'll right-click, we'll initiate takeover. Here you can select which database to switch roles with. In this instance, we've only got one secondary, so we'll choose that secondary. You can see that the services stop for the primary and that the secondary has assumed Site B secondary has assumed the primary database role. Now you can see that the secondary database role is under Site A primary. You can also see that the information has been updated, and you can now disable your primary connection. And now that it's disabled, you can close it, do what you need to do, take it offline. We'll re-enable it in this instance. It's catching up now to the primary. The primary is on the left. And now we're going to switch back. So we've done our maintenance and we want Site A to become the primary again. We'll do another conditional takeover. And as you can see, the primary database role switches over very quickly. It takes a little bit more time for the secondary database role to be reassigned, and then it catches up. Now that I've shown you some things you can do in SDS admin, I will now show how you can utilize SDS methods and notifications to run your own applications using Jade code. For the purposes of this demo, I will use a scheme I have created which demonstrates some of the capabilities of Jade database admin methods and SDS notifications. I have decided to display everything with a user interface so that people can see what is happening easily, but one can perform the same procedures in applications without a user interface. I'll now run through some things you can do with this application. Firstly, I can show the state. So you can see that site A is SDS primary and site B is currently SDS secondary. And then you can also add objects on the primary. So as you add objects, you can see that there's an OID there, and that is displayed on the secondary. So as you add more objects, that's being updated. And you can also delete objects. And then that appropriately displays on site B as well. You can also read objects on your secondary database. However, if you try and add an object, you get an exception. And normally in a production environment, you'll like to handle that exception. In this particular instance, I've shown it just to show that the secondary database is read-only and doesn't allow updates. I'm now turning logging on for both of them. And you can see this current database info. Now I'm going to perform a takeover. So on the primary, you can implement a negotiated takeover, and on the secondary, you can implement a hostile one. So if you press OK, you can see on the logs, it actually updates and shows what state it is in right now. You can see the bottom has quickly assumed the primary SDS role. It takes a little bit more time to assume the secondary SDS role for site A, and you can see the log of all the times to the right. And now you can see when you click Show Database Info that the SDS primary is now on site B and SDS secondary is on site A. So I'm just demonstrating that you can add objects now, always on the primary, delete, you can read it. And again, if you try and add on the secondary, it's an updating transaction, which is not permitted. And now let's perform another takeover. And as you can see, site A has quickly reassumed the primary SDS role. And now the secondary SDS role is on site B, and you can see which times these connection states happen. Say you wanted to get information about your SDS, primary or secondary. There are a set of functions on Jade Database Admin which can help you get this information through properties on a Jade dynamic object which you pass in. An example of this is the method SDS getMyServerInfo. I will demonstrate this in a bit. So here I am showing the primary's IDE. If you have applied a developer's license to the secondary, you can also start up the secondary's IDE provided your database has read access. Note, you cannot change anything in the secondary's database, so if you start up the IDE for the secondary, you'll only have read access as demonstrated there. So now I'll close that, and first thing I'm going to do is I'm going to create a class, and the class is going to be called SomeObject. And oops, that's not quite what I want. So now I'm going to try and delete it. When I try to delete it, it says you cannot delete it from the current schema context. So what you have to do is right-click it, the schema, version it, and now you have the latest schema context, which is the one I've just clicked on, and I can delete it from there. And then when I perform a reorganization, you'll notice that the class has been deleted. And the reason why you cannot do this is because we need to force a schema transition on the secondary so that the secondary applications behave as expected. Okay, so now I'm going to create a new Jade script. And I'll just call it InspectMyServerInfo. Okay, so what we're going to do is we're going to start off by putting in our variables. So we've got the Jade Database Admin, which is where these methods reside on, and then we also want the JDO, which is the Jade Dynamic Object, which we're going to populate with the information. And now I need to create them. I'll create them transiently. And now I will call the method on JDA SDS getMyServerInfo with the JDO object as a parameter in there. And now I will just do a JDO inspect modal. And what this will do is it will inspect the JDO object and its modal, which means it will pause the execution so we can see what's happening. And then I will clean everything up. So I'll delete my transients. And then I will run this. Okay, so when you run it, you can see some information that it's been populated with. There's my name, current journal number, etc. And we'll take a look at this max committed tran ID. So what we're wanting to do is we are wanting to now potentially output some things. I will want to now write out the max committed tran ID. So what I'm going to do is I'm going to use the JDO.getPropertyValue, and this will get the property value of a particular property by its name. And in this case, it's the max committed tran ID, and it's case sensitive. So if you do accidentally change the D from capital to lowercase, then it will throw an undefined property exception. We'll get rid of the inspect modal, run it, and we see that it's 3248. So that's what it is currently. And then now what we're going to do, a thought, is what happens if we create a demo object. Now you probably don't want to use reserved words, so we'll use D for demo object. And we will begin the transaction, and we will create a persistent demo object. And then we will write again the JDO get property value of the max committed tran ID. Now, technically, after you've done the transaction, this should have, and it's been committed, this should increment the transaction ID. So if we run it, what do we get? We still get 3252. Now, the reason why this happens is because every time you call SDS get my server info, you're essentially getting a new object with a snapshot of the server info at that time. So what you need to do is actually call the JDA.SDS get my server info again to re-get the server info, and it repopulates the JDO. And you can see that the max committed transaction ID has incremented this time. This works if I have only specific moments in which I need to get the state. In this instance, when I press the button for my demo and show DB info. But what if you wanted to check when a state has changed? Ideally, you do not want to recall and recreate this object frequently to get the state, because it will tank the performance of your systems. So this is when we go to notifications. SDS notifications. There are 3 different types of user events you can cause on the primaries and secondaries. You've got your standard cause event, which notifies subscribers on the primary only. You've got SDS cause event, which notifies subscribers on secondaries only. SDE cause event, which notifies both primary and secondary systems that subscribe. I have prepared a stripped down version of the system. I will go through how to set up different kinds of notifications in different scenarios. So I'll just show you. Firstly, I'd like to send a notification to my secondary every time I've added a demo object. As you can see, currently it doesn't. It still reads. When you delete and you read, you can still see it, but no notification has been sent. So what we're going to do is, normally you'd want to use a system notification on the class of demo object whenever it creates a new object. But in this instance, we're going to use system.sds cause event. And we're going to use my defined constant at demo object false. You want the immediate to be false because you want it to be after the transaction has been sent. And then you've got the self, which is the demo object itself, so we can get the void. Now I want to begin the notification in the form, because this is where the notification is going to have an effect. So on begin notification, I need the object, the event types, and I also need some more information. In this case, we'll just add demo object as the event tag. And then on the user notified, because we're implementing a user notification here, we need to say if event type equals, and we specify what the event type is. Then what we are going to do is, as per the method I showed you earlier, we'll first cast the user info, which was we passed ourselves through, which was the demo object, to a demo object so we can get some information. And then now we will do a notification update, which essentially updates the text box as shown earlier of the primary has added a new demo object. And then we'll give it some information. Let's give it its name. Okay, so we've finished that. And now that's compiled. Now, in order to make sure that the states are the same, we're going to relaunch our two applications, the primary and the secondary. Again, I have set up some scripts to quickly run this. And now I've got site A and site B. So now when you add an object on site A, you can see that it's been added. You can see that the notification has gone through to site B. And you can see that the number increments, and when you delete it, again, same, you cannot delete on the secondary, and you can still show all the DB info. So that's one way to handle user notifications. And now with the power of editing magic, I have implemented something similar on Purge. So if one were running only the secondary application on site, we can monitor what might be happening on a primary system remotely. So now we will see how we can use SDS notifications to log state changes during a takeover. For the purposes of visibility, when I say log, I will write the output to the screen, but you can log to a file or however you desire. So currently, here's the add, here's the delete, and you read, and you show the DB info here. And when you perform a takeover, it says, okay, attempting takeover, and you have got no notification on your secondary as to what's happening. You just have to press show DB info and really hope that that's happened. Again, on your site A, as it reinitializes to its secondary role, you have to click show DB info and hope that it's currently in the right state. And again, taking back over again, there's no information on whether or not it's assumed the new state, so you really just need to hope. So we're going to change that by using notifications on the state. There is a particular notification called SDS role change event. And this role change event is a notification that gets sent whenever the SDS has had a role change. So when the SDS role change event notification is sent, it's been sent with a particular user info, which is an integer constant, and that represents the new role of the database. So what we're going to do is we're going to begin notification on the form that we're listening to and user notify again. And in the user notify, we're going to add an extra statement in here. Else if, so now we check the event type, and we're checking for the SDS role change event, which is an integer. That's just defined as a constant here. And if user info, and so the user info which gets passed through is also an integer. And if that equals the defined constant, which is SDS role primary, then now you know that you have swapped over and you're now on the primary. It's now got the primary role. So we'll just say assumed primary SDS role. Now when you swap over, you can see exactly when your old secondary, Now primary has assumed the primary SDS role, and we'll do exactly the same thing, this time with the secondary role. So you're checking the secondary role so you can see exactly when your old primary system has now assumed its new secondary SDS role. What we're going to do is we're going to close them to make sure that they're all in the same state, restart them. Okay, so now let's add our objects, etc. And then now let's perform the takeover. And now you can see, now take a look at the text box, you can see it's very quickly assumed the primary SDS role. It takes a little bit more time to assume the secondary SDS role from the old primary. So now we know, and we don't have to constantly press the show DB info. We know exactly when it has assumed their new roles. And that's just taking over again. And there we have it. So now with some more editing magic, as you can see, we can log some extra information about state changes with all with using notifications. So I've turned logging on, and now we're going to take over, and this is all done through notifications. And then so now that we've done that, what we can do is, as you can see, the database operations work perfectly fine on site B being the primary. Now let's just take down site A for routine maintenance. So we'll close those applications. We'll get rid of the database node. And then now you can see that you can still use your site B as your primary perfectly fine. Your secondary is offline. You can still read objects. Everything works as it should be. And now you've finished your maintenance. So let's start it back up again. So we've started up the database for site A again. And we'll start up the application again. And we'll try and put that into the corner. And double click to show some logging. Okay, and now let's perform a takeover. You've finished your maintenance. You want site A to be your primary role again. And as you can see, site A has very quickly assumed the primary role again. And we'll just wait. Here we go. Site B is now your secondary again. So that was some really quick maintenance that you've done and a quick switching back. But it shows how easy it is that for you to be able to take down one server, do some maintenance, and put it back up again and resume everything as business. And so finally, I will finish with a few considerations to make when writing applications with SDS. So an important consideration is generally journal management. So with many systems and many transactions come many journals, which can take up a lot of space. Keeping enough journals to recover information lost is important. And before you change any archiving journal behavior, please carefully read the information available on the Jade documentation website. And when we went through notifications, we briefly touched on how regularly getting all the state information in a loop can impact performance. Likewise, having SDS admin open, which regularly gets the state of the systems, can impact performance of your system. SDS admin is good for diagnosing problems and occasionally performing tasks such as takeovers. However, having SDS admin open for regular monitoring in production systems can cause significant system slowdown. And this is where using notifications is particularly useful because you can monitor specifically for state changes without significantly impacting performance and only for the state changes which you care about. Another possibly obvious impactor on performance is the connection between your primary and secondary. If the network goes down, the secondary is designed to continue when the network goes back up again. But if your network is consistently unreliable, it can be difficult to transfer information from your primary to your secondary in the first place. Finally, does your system need SDS? Well, it comes down to the question of disaster recovery. If you can tolerate having your system down for a few hours and recovering from a backup, and perhaps an incomplete recovery if you have lost the journals on your main system, then you might not need SDS. But if you need to manage risk and keep high availability, it is well worth your time to consider if SDS can be used to benefit your business and customers. Thank you for watching this SDS Insights, and hopefully you've learned something from this and you found something useful and you can implement it to make your systems more efficient and performant.